So if you've been following my videos, you should be somewhere here, and I'm going to change the style. This will be more of a code along tutorial, and it'll be much more slower paced, and I'll try to leave as much as I possibly can while remaining somewhat entertaining and staying on point. I'll try to make mistakes and walk through what I would do if I were to start making a game. And I know originally I had started to hint toward making a platformer, but I decided to not get into that, just because if you're going to do a platformer, we're going to need a main character, a lot of character control stuff. It might get pretty advanced pretty quickly. So I thought take a step back and kind of scale that down and make a mobile game. This will be just for children, and it'll be top down, looking at a screen. There'll just be kind of bubbles that bounce around your phone, and you just pop them, and maybe there'll be colors, and I'll kind of make the gameplay up as I go. And if anybody has any opinions on what they'd like to see, or they have cool gameplay mechanics that they would suggest, we could also work that in. So let's get started on this. And I thought it'd be worth mentioning too that we also have GitHub set up, we have Unity set up, Visual Studio Code set up as well. And if you haven't seen any of those videos, I would recommend taking a look at those. That way you're kind of setting up the same way I am, in case something seems a little bit different from what I'm doing versus what you're seeing. If not, doesn't really matter. There's still going to be a lot to learn, I think, from this if you're new. I also thought as a fun bonus that we could treat this as sort of like a real project if you were working in a team using GitHub and actually doing game development, in case anybody was curious how you would do that. I'm going to be using Trello, and I'll start by, we can kind of lay out some cards in the to-do and move them along as we work on them. So for this game idea, in a top-down kind of kids game where there's going to be bubbles bouncing around, the way that we're going to do this is there's going to need to be some edge detection around your screen, so that when the bubbles bounce, when the bubbles hit the edge of your screen, they bounce backwards. So there's going to need to be edge detection for phone, tablet. Just click add card. And then I have a plugin here that puts a number, and then we'll use that number to, when we do our branching in our pull request, so that we can track that, make this feature, write all the code, commit it, and then push it up and merge it into master, and then create a new branch, start a new feature. That way it'll work essentially like how you would if you were working on a professional team. So edge detection for phone, tablet, and then we'll need to make a basic bubble that bounces. What else will we need? And then we'll do touch input to pop bubble. And we'll do one for design background, design bubble, and then we'll do add bubble pop sound. I think this is enough for now, but this, you get the gist of, create some to-do list of things you're going to do, prioritize it however you want, and then so we'll start off with this one. We'd move it into working on. Once you move it into working on for you would go into your GitHub, and then we would create a branch here. So create new branch, and what was the number of that one? That was number 11. So then we can create a branch, and we'll name them all like maybe BR dash, then the number for that Jira. So BR11. Sure. Okay, so now we're currently sitting on branch BR11. We go over here. This is where we started. So first thing we're going to do, like I said, we're going to set up the detection around the edge of the screen. So let's get started on that. Let's start off by going to global volume. We don't need our post-processing effects right now, so just drop that down to 0. We don't need this circle right now either. And for the background, since this is going to be kind of bubbles, I'm thinking it'll be in like a living room setting. So what I'm going to do is make this like a light-ish brown for now, kind of indicate hardwood flooring, but we'll get into designing that later. So not the most appealing, but this is going to be a mobile game as well. So another good thing to do would be in the bottom left here, change it from game to simulator. And now you can see we're like simulating in Apple iPad 5th gen. Doesn't really matter what this looks like. We can go iPhone. Let's start with iPhone for now. Ideally this would be like a tablet game, but we'll make it work for everything. That's a good start. Our phone setup. Now let's set up the barrier. So in Unity, there's going to be lots of ways to do various aspects of game development. And when it comes to something like hits and collisions and that sort of stuff, you can either go with Unity's built-in physics engine and it'll kind of simplify a lot of stuff for you, but you may not have a lot of control where you may want it. So your alternative would be to move everything manually in code, and for something like you'd use ray casting or something to detect if there was a hit, and if you notice a hit, then you would either bounce back in the opposite direction, so you'd forcefully kind of change the velocity that your object's heading in. So in order to avoid having to get too complicated, we're going to stick with the basic Unity physics engine, and I'll show a basic demo pretty quickly of how bare minimum what that would take to set that up, and it's pretty quick. We can go 2D object, sprite, circle. Now you see we have a circle here, and a 2D sprite, square. Change it to be something like green. Move it down and scale it out. Now you can see we have a ball and a platform. And currently, if you were to hit play right now, it would do nothing just because these are both just currently sprites. So it's rendering out a white circle and a green rectangle. Now, to make this actually have physics and behave as such, you would go to the circle, add component, can't type, rigid body 2D. You'll see here that there's the gravity and the mass and some basic stuff it needs to calculate the physics. And if I were to hit play right now, you'll see that the ball now drops because there's gravity being applied to it. And then it also passes like right through the platform. The reason that's passing through the platform is because it has no way of knowing that there's a collision. In order to do that, you have to go back, add a component, and you can start typing collider, and you'll get a bunch of options. For the circle, obviously we're going to want the circle collider 2D. Once you add that, you're not going to notice much, but if we zoom in here to the circle and you go to edit collider and you just click that, I don't know if you can see that, but there's a small green line going around here now, and that's kind of showing you the outline of where the collider is. So now the circle has a collider. Again, if we were to hit play, it would just fall right through again because our platform down here doesn't have one. So on this one, you're going to want to add a box collider 2D. And you also have to be careful here. It makes a difference. If you're in a 3D project, everything should just be the basic box collider, etc. If you're in 2D, make sure you always select 2D. Same for rigid bodies and everything. So rigid body for 3D and all the other colliders for 3D. If you're in 2D, rigid body 2D, and colliders, everything has to be 2D or else it won't work. Alright, so now that both objects have colliders on them and the ball has a rigid body, which is also important. If they both just had colliders, it still wouldn't do anything. One of them needs to be a rigid body. Now if we click play, you should see it fall and hit the platform and stop. Like that. So as you can see, like with no coding, we already have collisions working. So if you were to do this without Unity's built-in physics, you would have to write all that logic yourself. We don't need this. Actually, we don't need both these anymore. Let's go right back to the basics. 2D sprite square. And we're going to build a barrier. So same concept applies here. We're going to add a box collider 2D. And you'll notice that it is by default, your square is going to be a 1x1 unit. Now that we have our square, we're going to want to make this into a prefab. So in order to do that, we're going to call it barrier first. Important to name your object before you make it a prefab. We'll create a folder in here called prefabs, and then drag that object into that folder. And now you see it became blue. So I'll do another video on prefabs, but essentially prefabs are like the bread and butter of Unity, and in a nutshell basically allow you to create X number of versions of this thing, and if you wanted to make any modification, you can make modification to one and it would cascade to all of them. I don't know if that's a very good explanation, but anytime you're doing anything like for example coins, the coin would be a prefab. You would spawn a lot of these coins, and each individual coin would be programmed so that if you were to interact with it, you would increase your score, and it would play a sound, etc. But then, you know, obviously that may change at some point. So if you were to go in and take that coin and change the graphics of it, you wouldn't want to go back through all the coins in all your game and have to make that same tweak. So if you use the prefab in this instance, they would all be kind of a replica of each other, and adjusting any of them would cascade those changes out to all. And that's what we're going to do here. So very simple to make a prefab in Unity, like I showed you. You just create your object, drag your object from the hierarchy into your project, and it'll create it as a prefab. So now what we're going to do is on your camera, add a component. We'll call this barrier. I think it makes sense to live here. So the camera will be responsible for making the barrier going around your phone. And if you double click that, if you double click the component that we just created on the camera, it'll open up in Visual Studio Code. So these are the two event methods that come by default when you make any component script on an object inside of Unity. And it's worth being aware of how many there are and like how they run. So if you open Unity's documentation and go to the lifecycle overview, you'll see all the different events that can happen, and you'll see the order in which they execute, which will be very handy to know for a lot of different coding challenges that you're going to encounter, and why you would put maybe some code in one of these blocks and some in another. And it's also worth noting that fixed update and update are called very frequently. So I'll link this in the description below if you want to take a look at this. But this is good to have in the back of your head, even early on, if you don't quite understand it, that this is what Unity does. So for now, the basics that you just really need to understand is that update is called once per frame, as it says right here. You need to be careful about the code that you put in here because it's going to get ran constantly. However, start's only going to get called once, right when this, the first frame update that this is called. So the first thing we're going to want to do is create 4 barriers. We're going to have one for the top, one for the bottom, the left, and the right. So to do that, we're going to need a reference to the prefab that we just created. Let's create a game object here, and we'll call this the barrier prefab. Now that we have that barrier prefab, what you want to do is instantiate that. So it's sitting in our project. Basically what you do is every time in code we call instantiate, it takes that prefab and then it injects it into your scene. So you run something like instantiate, you pass it the barrier prefab, you give it a coordinate, so that would usually be what we call vector 3, and you give an XYZ coordinate for where that's going to be located when it instantiates. So when you put in your scene, where is it going to be positioned, and what's its rotation going to be, which in this case you just put quaternion identity, and I'll show you what that means. So basically all you need to know is we're instantiating this prefab, this is the location that we want to put it, and this is the rotation that it's going to have. And the quaternion identity is just saying leave the rotation as it is, and I'll show you this, like, or saying basically leave as no rotation. So the object will be aligned with the world or the parent axis. Go back into Unity. We can now delete the barrier game object that's sitting in the hierarchy. Click the virtual camera. The barrier script component now sitting on the camera, you'll see that there is a barrier prefab box here. Basically this happens because you put public on a variable and it'll allow you to change it here in the editor. So what you would do here now is drag that prefab and place it into that box. And now you're going to assign it to be that prefab. Another way that you can do this without using a public variable is to make it private, for example. And above you would add these square brackets and call this a serialized field. So if you save that, you'll see that there's going to be no difference. If I took away the serialized field, this would disappear from the editor. In fact, this is probably the preferred method, that your variable should be private. It should only be public if you plan to be interacting it from another script. But if you just need to make changes inside the editor, I'd recommend throwing a serialized field on there and calling it private. Now that we have that set up, let's hit play and see what happens. Alright, and as you can see here, the barrier prefab got instantiated, and you'll see in the hierarchy that gets created here with the brackets clone. And you can see the position is 0, 0, 0 and the rotation is 0, 0, 0. So that's what we set up. So now what we're going to want to do is create 4 of these and have them positioned at the top, bottom, left, and right. In order to do that, let's go back into the code and let's just grab this and paste it 4 times. So we're going to create 4 of these. We just need to change the position for each of them. And in order to get the position, this is where things get, again, a little tricky, because where things are located on your screen is not the same as where they're located within the game world. So this is a very common thing where you want to get a point from your screen coordinates and translate that into world coordinates. And in order to do that, you need a function like camera screen to world point. And here you can see an example of that. So it's probably easier to just show you how that works. First things first, create a private camera variable, and we'll call this just camera. And I'm also going to start using the awake function here. So the awake is going to call before start. And this is generally the function that I like to instantiate all my components or initial variables. So here I'll put camera equals camera.main. So this will get the main camera of your project, and we're going to store that in the camera variable. So now we're going to come up with the 4 positions of where these need to be placed. So we'll do, for example, vector 3, top barrier, or top position equals, in order to do this, you do camera dot screen to world point, and then you pass in a new vector 3. And so in order to get the screen coordinates, you can access an object directly called screen and get the width. You can also get the height and the camera. No, not the full camera, the camera near clip plane. Oh, so I had to flip back there. I needed the camera near clip plane. So like this. And then we'll comment these 3 out for now, and then we'll see what this gives us currently. So if you hit play on that, you'll see that there's a square in the top right corner of our screen now. So just to check, we were to do bottom, and we did 0, 0. In theory, I believe that should go to the bottom left. Flip back to Unity. Yeah, so if we hit play here, you'll see now we have a square at the bottom left and in the top right. So we're getting there. Ideally, what we want to do is put them in the middle of the top, middle of the bottom, and left and right, and then have them scale up according to the size of the screen. So in order to do that, we're going to need 2 more. We'll do left position and right position. Uncomment these 2 and replace these as well. So now all 4 are set up. And so basically, like we just identified, that 0, 0 is going to be in the bottom left, and if you do screen width and screen height, you're going to be into the top right. So the top middle will be screen width divided by 2, and then into the screen height. Bottom is going to be, again, screen width divided by 2 for the X, and the Y will be 0. For the left position, I believe that is going to be 0 on the X, and screen height divided by 2. And the right position would be screen dot width and screen dot height divided by 2. We save that. I think that should give us what we want. If we go back to Unity and hit play, hopefully there will be 4 squares sitting in the positions that I just talked about. Yeah, so if we hit play now, you'll see we have a square at the top, bottom, left, and right. You also notice in the hierarchy view So you just see barrier clone 4 times. So this may get a little confusing if you're trying to debug your code using prefabs, which code is running where, especially when you're moving positions around like how we are. And a quick way to remedy that would be to, before we get any further, can do is create game object top barrier, and paste this out 4 times, and then just again call this bottom barrier, left barrier, right barrier, and we can do top barrier dot name equals top barrier. And then just paste these names out. Okay, so just like that. So now inside of our Unity project, what should happen is when we hit play, when these get instantiated, all the names will show up in the hierarchy so that you can easily identify which prefab that we instantiate that we're referencing here in the hierarchy. Just to confirm that we do have the right ones in the right position. So again, now you can see top barrier, bottom barrier, left barrier, and right barrier. So everything is how we thought it was working, and everything is set up. So the only thing left to do now is to make these expand and fill the height and width. So now that we have this, what we want to do is for each of these obviously to scale to cover the entire side. And in order to get what the screen width and the screen height is in world space, it's pretty simple. Since we already have these, we just need to subtract the left from the right to get the width, and we need to subtract the top from the bottom to get the height. And what that looks like in code is you would do a float screen width equals the top position dot nope, you would do the left position dot x minus the right position dot x. That should give us the screen width, and the screen height would be the top position dot y minus the bottom position dot y. So float's just saying that we're expecting to get a number back from this. And now what we would do is say top barrier dot transform dot local scale equals new vector 3, and in here we're going to say the screen width, because we want this one x to expand to the width, the y we want to leave it as 1, and the z we want to leave as 1. And the reason that I'm talking about the transform here is because off of the game object itself, if you're looking at Unity, if you click here, you'll see that there's components on the right, and transform is one of them. So when you're talking about position, rotation, scale, if you're trying to make any adjustment to that, you would say game object dot transform to reference into here, and then you would say dot position dot rotation dot scale. And if you just reference them as is, you're talking about world space. But if you say local scale, you're talking about relative inside of this actual object. So literally what we're going to be doing in that code is taking that x value and hopefully moving it to be exactly the screen width. So if we hit save there, so So yeah, you can see that now that is expanding the top square to be the size of the screen. So the only thing left to do now is get the bottom to do the same thing and the left and right to scale up to be the height of the screen. So now we just need to do the other three. And that should be pretty straightforward. So we should create three more. The bottom barrier, left barrier, right barrier. For the bottom barrier, that's going to be the same thing as the top barrier. For the left barrier, you want 1 for the X, and you want to scale the Y up to be the screen height. And again, same for the right barrier. So 1 and screen height. Now if we save that, and now if we hit play, you'll see that everything's expanding and we've done exactly what we want to do. So now the barrier is going around the entirety of the phone, and just to show that this is in fact working, we can try and change this over to be an iPad, and if we were to hit play again, this should perfectly barrier the iPad as well. Yeah, so there we go. Now the only issue left is that the square is a 1 by 1, and essentially the centers of these are what is where the position's going. So what we want to do now is shift it over a half a unit to make it go to the actual outside and not have anything kind of overlapping into the actual screen. So now in order to do that, it's pretty straightforward. Since again the squares were just 1 by 1, you move it over by half a unit. Problem is we don't want to do that in the screen to world point. The position that it becomes afterward is where we'd want to make that change. So now in here for the top barrier, we want to, it's going to get confusing. So we want a new vector 3. We want the X from the top position. We want the Y, and Z can remain 0. What we want to do is on the Y, we want to add 0.5. I think this should push it up a half a unit, and it'll be on the outside of the screen. So if we save that and go back to Unity, yeah, there we go. So now when we play inside the iPad, you can't see our object at all, but on the outside you can see it's there. So that's perfect. So now we just need to do the same thing for the other three. So if we grab this, but then we're going to need to make sure that it's the right one. So bottom, bottom, left position, right position, right position. Okay, so for the bottom position, this is going to be minus 0.5. So for the top one, it went up half a unit. For the bottom one, it's going down half a unit. And for the sides, they're going to go out half a unit each as well. So for left, we're going to want to change the X to be negative 0.5, I believe. And then for the right, we're going to want to be plus 0.5 F. Save that. As you can see, this is getting pretty complicated just for moving the barriers to be the outside, but it is dynamic. It'll work on all phones and tablets and everything. And hopefully going step by step that this made sense of how you interact with all these game objects and change their locations and scales. Since this will be very common, you'll probably be doing this in every game that you make. Boom, there you go. So perfect. Now we have a barrier going all the way around our phone, tablet, whatever it is, and it's already set up with the collider. So now we can make anything we want on the inside, and it should remain inside of our phone. So I'm going to say that this is done now. And what we can do is commit this to our branch, and we can merge that back into master and say that this feature that we're working on here, which we identified over here for the edge detection for the phone, that we're going to be done. So let's open up this, and then we can see all of our changes here. Oh, I think we need to make sure that everything in Unity is saved. Okay, go back here. And then we'll say that we add barriers. And then we'll call this the BR11. Doesn't hurt to have a description. You can write a little bit more of a detailed description if you want, but adding barriers, put a description, it's on the branch. Now we can publish the branch. We can create a pull request. See, it opens up GitHub here. Now we have a pull request from BR11 going into master. Click create pull request. You can see the files changed. So here's our barrier code that we're submitting, and then these meta files are just, you can ignore those. And this is the prefab. That's it. Now we can merge that pull request, or you can have your team or somebody else can look at the code if they want to. And now if we go back to bubbles and master, that's been merged in and our code's up to date. So we're now done that ticket. We can go over here, move that over into finished, grab our next one, put it into working on. Now we're going to be on number 12. So what we can do is go back to master. We can fetch that, make sure everything is up to date, pull from origin because we're now behind. So now our master branch is up to speed with what's on GitHub locally. And now we can create our new branch for this new ticket for making the basic bubble that bounces. So create our new branch following the same pattern, basic branch 12. Create. And now we're set up for our next ticket. So hopefully that makes sense. Like, if the reason you want to do this is because you might start in the middle of your project, have an idea, or you might want to tackle the next thing, and you start working on it, and what you notice is that something you did just broke something, and maybe you can't figure it out, and you've been working on this for several hours, several days, and you want to abort. You want to forget, I don't want to work on this anymore, I don't like how it's going, but I don't you basically just want to revert, go back to where you were before you had this. And if you're on a branch, it's a simple thing to do. You just go back to master and you're back to where you were before you started working on that piece of work. So it's very handy to have. It's very handy to be kind of disciplined to do that, because there's many times where if you are just working, that you're going to kind of run into this scenario where you're going to have a hard time finding your way back if you need to. Now that we have this new branch set up, we just need to make a basic bubble that bounces. So this is pretty straightforward and easy to do now that we're using Unity physics. All we need to do, like I showed before, is go 2D object, sprites, circle, and we can scale this up by 2, just to make that a little bit bigger. And like I showed before, we're going to want to add a rigid body 2D. And we're also going to want to add a circular collider. Perfect. Now if we hit play on this, you'll see it falls down and it hits our bottom barrier. Which is good if you're making sort of a 2D platformer. Basically your gravity is going to be down, but since this is going to be a top-down screen, we don't want gravity to be on. And the way you would do this is open up your rigid body and for one way you can do this is just change the gravity scale there to be 0. We don't need no angular drag either. Another way that you can do that is, I think if you go into preferences, nope, not preferences, and project settings. So over here in project settings, you'll find physics 2D. So again, physics 2D if you're in 2D, physics if you're in 3D. And in here, you'll see gravity is -9.81. So you can also just change that to be 0. And that would essentially do the same thing. There would be no force pulling it down on the y-axis. So now, the only thing left to do is, since we're not going down, we're going to create a script on here. We'll just call it bubble. And we can also rename the game object to bubble and drag that into our prefabs as well. Since there's obviously going to be more than one bubble, it's probably going to be a prefab. Makes sense. Now that we have that, let's open up the bubble script on the bubble object. What we're going to want to do for this is when it starts up, let's get that rigid body and then add a force. So the rigid body is how you're going to interact with the physics of this object. And in order to do that, you would set up a rigid body 2D variable. We'll call this rigid body. Again, make the awake function inside the awake. Set rigid body equal to get component rigid body 2D, like this. So this is the first time we're doing this, and again, this is very important. You're going to do this a lot in all your games. What we're doing is setting up this variable called rigid body, and the first thing we're going to do in the awake function is grab a component called rigid body 2D off of this game object. So if we go back into Unity, where this script is, so this script, bubble script, is sitting on our bubble game object. Now, also on that game object is this rigid body 2D component. So if your bubble script needs to interact with this component, you need to reference it by calling this get component rigid body 2D. So you can do that simply because they're both scripts are existing on the object. You can fetch other components on that object. If, for example, the rigid body wasn't on this game object, but it was kind of in a nested game object, then you could do something like get component in children, or you could do opposite, like get a component in the parent. So there's other identification methods of getting components off of various game objects, but typically the average use case, you're going to usually get the component off of the same game object that this code is also existing on. So that is very, very common. So hopefully that makes sense as well. So now that we have this, now that we have the reference to this rigid body component that's existing on this bubble object, what we can do is say rigid body dot add force, and we can say new vector to random dot value, which is basically, we're going to say add a force to this bubble, and it'll pick a random x and y coordinate and throw it in that direction. And then you're going to want to normalize that. New dot add rigid body new vector normalized. Okay, and then the other thing is that's going to pick a direction, but the force applied to it is going to be very minimal. So we're going to need to kind of multiply that direction by a value, like the force that we're going to apply. So we'll call this something like bubble speed. And in order to kind of easily manipulate that variable, we'll specify it up here, bubble speed, which will be a float. And again, we'll call this a serialized field. Save that. And now we'll be able to edit that value in the editor, and we can play around with it to make sure that the bubble is moving at the correct velocity. Again, let's flip back over into Unity. And here you'll see the bubble speed now is visible to us in the editor, and we can just drag this over, say 40, let's do 30, 36, and hit play. So this should pick a direction, and yep, so the ball's now moving, the bubble's moving in that direction, and it hits the collider and just seems to get stuck. So this is obviously strange behavior for a bubble, not what we want. And I believe this is because of the physics material. So over in the assets, right click, go to create, go to 2D and physics material 2D. And we'll call this bubble. So in here, what we want to do is increase how bouncy it is. I think so 0 is not bouncy, 1 is max bouncy. Like it'll bounce almost like light would reflect, and make sure that there's no friction. So there's no friction when it impacts, it'll just keep bouncing. So if we hit save and hit play, so now it should do the same thing. It should pick a random direction, and then when it hits the barrier, it should bounce off. Or not. This might be due to the physics 2D settings. I think here is because it's going so slow in the way that it interacts, it's not bouncing properly, and I think that's because of the velocity iterations. Yeah, I think it's this one. So I think if we change this something to really, really low, that should solve that problem of it not bouncing off. Oh no, so what's going wrong here is that so we made this, now that we made this physics material 2D, what needs to happen now is on the bubble object in the rigid body, there'll be a material here for that physics material that we just made. Click that and select the bubble. Now we're going to apply that physics to the bubble itself. And then at the top right here under overrides, just click override and that will update the prefab itself. Now if we hit save and we run this, we should see the bubble bounce around the screen. There we go. Perfect. Let's also just take the bubble and let's crank that speed up so we can just see it bounce around a little bit faster. See if we like the way that that looks. I think that looks pretty good. I mean, the speed's too fast, but the way it's bouncing is pretty much what I had in mind. So I think this is good for now. We can call this part done as well, that we now have a bubble and it bounces around the screen. Yeah, so I think this is a good time to stop, that we have accomplished 2 tasks. So let's just save this, move this up to GitHub as well, and we'll go over that. So same step again. So now that we're on this BR12 branch, here's the new files that we just had. Let's say add bouncing bubble BR12, commit this, publish this branch, create a pull request. Let's merge this into master. Merge that pull request. Delete the branch. Oh, I think I forgot to delete the branch off the last one. Delete that branch. Now that's up to date. Go back to here. Push back to master. Do a fetch. Pull from origin. And now our master is in sync with GitHub and we have our 2 features accomplished. So next step, go back to Trello and move our working on over to finished. Great. So now what we want to do is do the touch input pop bubble next. So we'll do that in the next video, but this has been a pretty good start. I think we're making some progress, and if you have anything you'd like to add to this game or a direction you'd like it to go, please let me know down in the comments. If you liked the video, hit the like and subscribe button, and I'll see you in the next one.